Warm welcome to yet another discussion on GATE tutorials. Today we are checking GATE 2015 set 3 and again we are primarily focused on network theory. So moving to the first question, for the circuit shown in the figure, find the Thevenin equivalent voltage in volts across terminals AB. So it's a very direct question. We can directly mark the node equation. I am marking this node, that is V minus 12 by 3 plus V by 6. Now 1 ampere current is entering, so on right hand side it is 1 ampere. Now V into 1 by 3 plus 1 by 6 equal to 1 plus 12 by 3. 12 by 3 is 4. So V into 3 by 6, right? 3 by 6 equal to 5, or V Thevenin equal to 30 by 3, that is 10. 10 volt is the answer. So the Thevenin voltage is 10 volt. Moving to the next question, in the circuit shown, we have to find the voltage Vx in volts, right? Vx is the voltage across 20 ohm. So it's a direct question. We can write the node equation Vx by 20, right? Vx by 20 plus Vx minus voltage of this node is 0.25 Vx. So Vx minus 0.25 Vx by that resistance 10 ohm plus next this node is same as this node, and at this node a 0.5 Vx is leaving. So at this node a 0.5 Vx current is leaving. So 0.5 Vx, right? Another 5 ampere current is entering this node. So equal to 5 ampere, right? Now we can simplify it, taking Vx common, Vx into 1 by 20 plus 1 by 10 minus 1 by 40, right? 1 by 40 plus 1 by 2 equal to 5. Now Vx into 40, right? Numerator is 2 plus 4 minus 1 plus 20 equal to 5, or Vx into numerator is 25. 25 by 40 equal to 5, or Vx equal to 40 into 5 by 25, or 40 by 5. 40 by 5 is 8. So answer is 8 volt, right? Voltage Vx is 8 volt. Now moving to the next question, at very high frequencies the peak output voltage V0 is, right? So at very high frequencies the capacitor behave as a short circuit. So I can draw the equivalent circuit. It is 10 volt, 1 sin omega t, right? 1 sin omega t V. Next capacitor is short circuited. Next a resistor of 1 kilo ohm. Again another resistor of 1 kilo ohm. Now the capacitor is again shorted. Now a resistor of 1 kilo ohm. Again another resistor of 1 kilo ohm. And again another capacitor, and it is also shorted. And we have to calculate the output voltage across these two terminals, right? So one parallel one is 0.5. Again another one parallel one. So again another 0.5. So the circuit can be simplified as this, right? Now we have to calculate the output voltage across this. That is exactly half of the input voltage. So peak output voltage is 0.5 volt, right? The input voltage is 1 sin omega t. So the output voltage is 0.5 sin omega t. So the peak is, as mentioned, 0.5 volt. Moving to the next question. In the circuit shown, assume that diodes D1 and D2 are ideal. In the steady state condition, the average voltage VAB across the 0.5 microfarad capacitor is. So we can first of all redraw this circuit, right? So I am redrawing it. First of all a 50 sin omega t, that is the source voltage. Next a capacitor of 1 microfarad. Next a diode is connected in this way. Next another diode, right? Another diode is there. and finally a capacitor in between these two diodes, and the circuit is connected in this way, right? This is diode D1, this is diode D2, and this is 50 sine omega t, and we are taking voltage across these 2 points A, B, and marked it as VAB. I am again redrawing the circuit into a much familiar form, right? I am drawing this diode D2 here, right, and a capacitor is here, and marking AB, VAB plus negative, right, plus negative. So this circuit is a familiar circuit, and that circuit is voltage doubler circuit. Voltage doubler circuit. Exactly speaking, it's half wave voltage doubler circuit. Half wave voltage doubler circuit. So the output voltage is 100 sine omega t. So across the 0.5 microfarad capacitor, the value is 100, right? Moving to the next question. In the circuit shown, the current flowing through the 50 ohm resistor will be 0 if the value of capacitor in microfarad is, right? So in the question, we have to find the value of capacitor such that the current flowing through this 50 ohm resistor is 0, right? Now we can write the effective impedance of this capacitor and the inductor. For inductor, it is J omega L. J omega is given as sine 5000 t. So omega is 5000. L is 1 millihenry. So 5, right? J5 is the impedance of the inductor. Similarly, for the capacitor side, 1 by J omega C or minus J by omega C minus J by, again omega equal to 5000 minus J by 5000 C. As capacitor is mentioned in microfarad, minus J 5 into 10 raised to 3 into 10 raised to minus 6 into C, right? So minus J by 5 on numerator side, I can mark it as 10 raised to 3 divided by C equal to minus J by C into 1000, right? 10, 100, 1000. 1000 by 5. 1000 by 5 is 200. So minus J 200 by C is the effective impedance of the capacitor, right? Similarly, inductor side we obtained it as J5. So now we can write the node equation, right? V by impedance of the inductor is J5 plus V. Now series combination of inductor and capacitor, that is V divided by J5 minus J200 by C, right? Next, the current flowing through this path, but in the question it is mentioned as 0, so we can write it as equal to 0. Implies V, I am taking V common, V into 1 by J5 plus 1 divided by J5 minus J200 by C equal to 0. That means either V equal to 0 or this term equal to 0. As V cannot be 0, this term must be 0. So 1 by J5 equal to minus of 1 by J5 minus J200 by C. Cancelling J on both sides, 1 by 5 equal to minus 1 by 5 minus 200 by C. Now I can write it as 5 equal to 5 plus 200 by C. Just taking inverse on both sides. That means moving this 5 to left hand side, 10 equal to 200 by C, or C equal to 200 by 10, that is 20. C equal to 20 microfarad. Right, so C is 20 microfarad. Now moving to the next question. The ABCD parameters of the following two-port network is 5 plus J4, 5 minus J4, 2 plus J0, that is 2 ohm itself. And we have to find the ABCD parameter of a T network. So first of all, we can write what is this ABCD parameter. V1, I1 equal to A, B, C, D, V2, minus I2, right? V2 minus I2, as current is flowing outside the circuit for ABCD parameters. Now the independent parameters are V2 and I2. That means we have to make either V2 equal to 0 and evaluate the values, or I2 equal to 0 and evaluate the values. So in a competitive exam like a GATE, we can find out the correct option. That may be a much better way of thinking than completely solving this solution. So as I mentioned, there are two independent variables, either V2 equal to 0 or I2 equal to 0. By checking the circuit, if I made V2 equal to 0, that means shorting the output port, it looks like this, right? But if I made I2 equal to 0, the circuit may be much simpler than V2 equal to 0. Circuit consists of only this part, right? Now I am making I2 equal to 0 and applying a 1 ampere current source here, a 1 ampere test current source here, right? So now I1 equal to, applying 1 ampere test current source at port 1 dash made I1 equal to 1 ampere, and this is port 2 dash, I2 equal to 0 for calculating other parameters. Now I2 equal to 0 makes A equal to V1 by V2. Similarly, again I2 equal to 0 makes C equal to I1 by V2, right? So that we are evaluating A and C. First of all, we can evaluate V1, right? V1 equal to current into resistance. Resistance is 5 plus J4 plus 2, right? Because 5 plus J4 is in series with 2. So 5 plus J4 plus 2 into 1, right? 1 ampere is the current source. So that turns out to be 7 plus J4. That is V1. Similarly, V2. V2 equal to 1 ampere current source is flowing serially through this circuit. So V2 equal to 2. 2 into 1 is 2. Right. Now we can calculate A. A equal to V1 by V2. That is 7 plus J4 by 2. So 3.5 plus J2. That is A. Similarly, C equal to I1 by V2. I1 is 1 ampere. V2 is 2. So it is 0.5. Now checking options. 3.5 plus J2, 0.5. Only one option is there. So answer is B. Similarly, we can try V2 equal to 0 and solve it. But GATE being a competitive exam, this may be a much better approach. For more GATE tutorials, subscribe my channel. So now I am signing out till we meet again with another GATE tutorial. Thank you.